This is the fifth and final note of Unit 6 on compound interest. Specifically in this note, we will be talking about changing conditions on investments and loans. So just to start off, just a quick term that you might not have known what it meant up until this point, and that term is actually term. So term, when we're talking about investments and loans, is the length of time that an investment is held or a loan is carried. Okay, so the amount of time your investment is sitting or the amount of time you have your loan in your hands before you pay it off. Okay, so just a quick summary here. Some truths about interest. So the higher your interest rate, the more interest earned or paid, or the higher interest earned or paid. Okay, so if you have a higher rate, so obviously if you have, let's just say 6.5%, is going to make you more money than 3%. Okay, so but on the other hand, if you have a loan at 6.5%, you're going to end up paying back more money than you would with a loan at 3%. So it kind of works both ways depending on what we're looking at. Okay, number 2, the longer the term of an investment or loan, again, the more interest you are going to either earn or pay. The longer you keep it in there or the longer you have a loan, the more money you're going to end up getting or paying. The more frequent the compounding period, the more interest occurs. Okay, or let's just say grows. The more frequent the compounding period, the more interest. Okay, so again, so that means if you have something that's monthly, it's more than something that is annually. Okay, the more periods you have, the more money you are going to either have to pay or you're gaining. For simple interest, doubling an interest rate or term will double the total interest for simple interest, okay? So if you have a loan that was at 3% and you change it gets changed to 6%, that means your total interest is going to double. So if you were initially paying $10 a month in interest and it doubled, you would end up paying 20% or $20 what did I say, per whatever time period it was. This is because simple interest growth is constant over time, right? Or linear. So that number is the exact same. It's $10, say, per month gaining interest, and that doesn't change depending on how many months you have it in there. For compound interest, on the other hand, doubling an interest rate or term does not double the total interest, okay? And we should know that because, again, this is exponential growth, okay? Exponential growth. Okay. So we just have one example in this note. It's quite short. So this example is going to show us kind of how changing interest rates and compounding periods affects our different loans. So I don't know how to say this. Joachim would like to have $8,000 in 5 years. Determine the amount he would need to invest at each rate to reach his goal. So our rates are going to be different for each of these situations. So A is 6% quarterly. B is 5.2% monthly. C is 4.8% weekly. Okay, so let's take a look at each of these. So 6% compounded quarterly. So we're trying to figure out our present value, right? Because we want to make $8,000 at the end of the time period. At the end of, what's it say, 5 years. Okay, so to figure out our I, again, we take our percent as a decimal, 0.06, divided by the amount of compounding periods per year, which is 4. To find our N, we take the amount of years, and we're going to multiply by that same number of compounding periods, which is 20. So we're going to use our present value formula, which is P equals A over 1 plus I to the power of N. So again, just a matter of substitution here. A, our amount that we want, our total amount is 8,000. 1 plus the decimal is just going to be 1 point the decimal to the power of 20. Okay, so we're going to, again, follow BEDMAS, so doing our exponent next. Finally, dividing those out. So in order to get $8,000 at this 6% compounded quarterly, he would need to invest $5,939.76. Okay, let's look at this next one. So what if we had 5.2% and we are compounded monthly? So again, I'm going to have to zoom in. Changing our percent to a decimal, dividing by our periods per year. So monthly is 12 months in a year. And our amount of years stays the same. We still want it to be 5 years, multiplying by that same number we divided by, and then using substitution to solve the equation for present value. It's always 8,000 on the numerator in this situation. That's to the power of 60. Okay, I'm not going to show all the steps on all of them, but you do the exponent first and then 8,000 divided by the exponent, or that total with the exponent. Remember, don't, if you reverse these, like if you take this bottom part and divide it by 8,000, you're going to get a different number. So you have to make sure that the 8,000 is divided by the decimal number. So don't reverse those. Okay, so that means we would have to invest $8,184.18. So let's just compare that to the first one. So even though we have more compounding periods, we can see that because our percent was higher in the first one, that was actually a better situation for us, right? Okay, looking at this last one, our I here, so we have 4.8% compounded weekly, so that's 0.048. There are 52 weeks in a year, 0.0009. And our N, again, is that 5 years times 52 weeks, which is 2,704. Does that make sense? 52 times 5? I feel like it does not. 52 times 5. Yeah, where the heck did I get that number? Okay, that's 260. That makes a lot more sense. All right. So again, just subbing into our equation. 8,000. On the bottom, we have 1 plus the decimal, all to the power of 260. 8,000 divided by 1.0009 to the power of 260. I have to redo this because I had the wrong number. To the power of 260. Write out all the steps for you. 1.2635. Means that our P, $6,331.56. So, can't zoom out anymore for you. Oops. So just looking at these different situations, so although the compounding periods, we're getting more compounding periods as we go to the right here, the percent seems to be affecting it greater, right? Because that first situation is our best case scenario, even though it's only compounded quarterly. Because the percent is higher, we can see that we would have to invest less money. Not a huge difference really between all of the answers though, right? Only about $400, but you always want to go with the best situation. So maybe at some point you might be going back and forth, trying to decide which loan you want to take or which investment you want to put into. You can use this formula to figure out the best situation for you, in the sense that you'll lose the least amount of money, right? So you want to invest the lowest you can if you're going to end up with the same amount of money in each situation. Okay, so this is the end of the last note of our unit on compound interest.